I figured I'd talk about my fastest, most efficient, simplest code. Why my design and my architecture yields the best code for programming. So the fastest code, the simplest code, the most efficient code. How did I come to get to that? So it's pretty easy. Programming has layers. There's a layer on the bottom called machine code. And on top of that, there's a layer called assembly. And on top of that, there's your C++ code that everyone's used to. So what I noticed was with the C++ code, if you switched the code around, it worked faster. So there's a line written in code here, and there's a line written in code here. And if you switch this word with that word and that word with this word and ran the code again, it worked a little bit faster. This is in one of the videos I was watching. So I said, well, why don't you just go through all the lines of code and permutate all the lines of code to so you go through all the combinations. So you go through all the combinations of code and find the fastest code. Yeah, exactly. Why don't you go through all the combinations of code, test them, and find the fastest code? And then you go down to the assembly layer, and you find all the code, all the combinations of code again. See, this would be very messy if you didn't actually have the intention of simplifying the code. So what we're trying to do is simplify the code and find the fastest code, and we're getting the computer go through all the combinations, and now you have all these the assembly code, which you could now have for every operation. It's more better if since assembly is like designed to be built. Going through all the combinations of assembly code could be crazy. It could be crazy, but if you put it to a task, if you say how do you perform this command in assembly code, and now go through all the combinations of assembly code to perform this command, you could get the best assembly code. And you do that to machine code, you go through all the combinations of machine code to perform the commands that you use in C++, and you get the best machine code. So the AI is designed to find the simplest, most fastest code. This is my AI back in 2008, I think it was, that I came up with this idea to go through all the combinations of code and test them. And you break it down into structures. And if you know what an API is, that's basically it's a book of commands. An API is like a book of all the commands you can use. It's kind of like that, right? So, what about now's AI though? What about now AI, where we're hearing about AI being able to code, right? Where it's being able, what's happening with now AI is that it's reading a book, it's reading tutorials on how to code, and then it's coding. See, so it's not actually searching for the most efficient code. It's not testing all the combinations of code, and it's not going for the most efficient code. But what AI does is very similar, or you can do a very similar thing to the AI that we're doing here, where you can test all the combinations of the AI, where you can get AI to learn to train on a program. So you have a program, and now you want the AI to train on that program and perform this program's function. So the AI is going to learn how to be this program. And what you can do is you can break it down to the simplest AI. You can go through all the combinations of what the AI is using and use the simplest AI to be that program. So 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 just like where you're going through what's the fastest, most efficient code when you're going through all the combinations of code, now you're going through all the combinations of what the AI learned. You're going through all the combinations of what the AI learned and coming up with the simplest understanding that will perform the task. So what this does is it not only gives you the fastest, most efficient code for your program, but if you're using an AI, the AI is now going to break it down even further, where you're using machine learning nodes, like this abstract machine learning node, instead of something logical like we understand. You're going to be basically knowing that if you use these three nodes this way, you will perform this command. I don't want to get into explaining this part because it's abstract, but what I'm saying is the AI will break itself down into pieces that we don't understand. It's going to break itself down into pieces we don't understand and use these pieces we don't understand to get the job done. And what you can do is now you can run everything through your AI and come up with the most efficient code. You can run everything where Elon Musk was talking about micro hard or macro hard, where he's going to do everything that Microsoft does, but he's going to do it with AI. This is very reasonable with what I've laid out in the past, where you have an OS kernel, and in that kernel you have one tiny little program, and what you can do is you can have an AI learn that program. So now you can have an AI for that program. Now you can go through the kernel and pick all the other programs and have little AIs for all the other little programs. And essentially, the other thing you can get the computer doing is creating its own AIs. So anytime it needs to learn something, it creates an AI to learn something. That's a good way. That's a good way to get AI to learn, is to create a new AI and then break it down to the most efficient AI for the system to use. So basically, this is an AI that trains other AIs. Anytime it comes up with a problem, it makes an attempt to train an AI and learn the problem, and then control the AI. But what we're getting down to here is the fastest, most simplest code, where you're now breaking it down into, we don't need lines of code in C++ and then assembly and then machine code. We can go straight into the AI, straight into machine learning, and pick out the best machine code, basically, best machine code that gets the job done. And we can break down anybody's code into the fastest, most effective, simplest form of code that's going to work and get the job done. And that's a key point to my architecture, because this allows you in the future to just go through the combinations, test the combinations, find the fastest ones in everything you do. Like, there's no more arguments about what is the best software architecture, because you'll be able to find the fastest architectures and then test them for stability and stuff like that. And then once you start testing them for stability and stuff like that, you have scientific, you have like a data, you have like a stats table of what's the best architecture, what's the best architecture for this, what's the best architecture for that. A lot of people will debate this and have arguments. Well, this was the fastest, most efficient, highest performing architecture. See, right now, that's the other thing, is software companies don't compare architectures. They, a lot of times, they don't have like a list of 10, 15, 20 architectures that they're going to try to compare against one another. They have like one or two that they're using, and the fight is, which one do you use? Right? The fight in the software company is, which architecture do you use? They don't actually run both at the same time. They don't actually run several architectures at the same time and then test them. See, that's the whole machine behind this AI, is that we're running multiple, or we're running all the architectures, running all the combinations, all the architectures, exactly, and we're testing them against one another for what's the fastest and what's the best. We're not just, I think if you're not doing this, they're just guessing. They're just arguing with discriminately, but they're just suggesting that their architecture is the best. They haven't actually proven that their architecture is the best. Like with this method, you've proved that this is the fastest, simplest code, and you prove that using this fast, simple code in this architecture, in this design, is most problem free. Maybe you're going for most problem free, but maybe you're going for fastest again. The most fastest, efficient way to use is the most fast, efficient architecture to use the code in. Exactly. So but this allows you to break down anything into what, like, if you take it out of code, if you take it out of machine code and go into straight into the AI machine learning nodes, you're breaking it down into like abstract computer points. Points that we don't even know what the computer means, but they work, right? Like it, it's like when I mentioned with the physics system, if you get the AI to learn physics, it's going right for you mathematical algorithms that we don't have. It's going to have different mathematical algorithms and different ways of solving the problems that we don't have. And it could be it could be fundamental to our learning to learn the best, most fastest algorithms for physics. Like when you have an AI writing different nodes, different algorithms that mean, or different nodes that mean different algorithms, it means there's a more efficient, effective, or faster way of doing this physics that we didn't develop, in our theories and in our writings, but through machine code and machine learning, it figured out the fastest way to calculate this. Especially if you're going to use a computer to calculate something, it might not just figure out the fastest way to calculate it. It might figure out the fastest way for a computer to calculate it, right? And a computer to understand it. And if you want to build a physics engine in the way what a computer calculates, to be pretty important, because that's what you're doing. You're cutting off the decimal points. You're rounding and cutting off the decimal points. And if you can avoid doing that, you get more accurate calculations. But for simplest code, it's run through all the combinations of the code and test them, and do the same with that AI. Run through all the combinations of AI and test it and make it as fast and as small and as efficient as you possibly can. And the structure that I laid out does just that. It does just that. It's a very powerful machine that will translate all the code. Like when you program, you're not going to be unsure about your code anymore. Your code's going to be tested and measured for the best and fastest code, and you're going to know that this is the best and fastest way that I'm building something here now. And it really empowers the individual programmer to, or like you think about an enterprise who has very big code and they want to break it down into a small amount of code that is very efficient and very effective and easier to manage. Anyway, as far as my company is concerned, this is a fundamental point, because now you got to keep this for all your code beyond. For like, you think of, we've only been coding for 50, 70 years, 50 years, 70 years. What about like 500 years from now when we've been coding? It can get pretty messy in 500 years. But if you keep this simple, efficient design at at the heart of your coding, it's not going to get so messy. It's going to get very familiar, and it's going to be like the knowledge that the computer teaches us. This is where the computer is going to teach us its machine learning. It's going to teach us its nodes. It's going to teach us what it's learning and why, and and it's going to be better than what we've done. It's going to be accurate and more faster and different algorithms, but better than what we've done on our own with our own writings and our own theory. So, okay, this is a ramble video, but still, simplest code, very important.